know we still have 2 minutes before the class. If you have any questions, feel free to ask me. You guys notice that I moved your homework assignment for chapter 1 due dates. So chapter 1 homework and quiz is moved.
You only put.
All right. Good morning, everyone. Happy Wednesday, mid of the week, and 2 more days, and then we will be done with this week too. As I mentioned, as I was mentioning 2 minutes before, I pushed your homework, chapter 1 homework and quiz due dates because we will not be able to cover everything on the right time that is assigned to your homework and quiz. I want to make sure that you understand those concepts first before you attempt those. And especially these concepts that we have in chapter 1 and chapter 2, we are going to use that in later chapters also. So if these concepts does not make sense now, they will not make sense later on, or you will struggle in the later chapters. So any questions for me before we start the class? Anyone? Just want to make sure that you can hear me.
Yeah, we can hear you.
Okay, perfect. Thank you. So today I am the connection is a little different today with my iPad. So at some point, if you do not see my iPad, which I see that you cannot see it right now, can you see? Nope. So I guess I have to connect it differently. Give me 1 second. Okay, tell me, what do you see on my screen? Do you see anything?
No.
You right now.
Okay. Yeah, so there were some issues with the iPad connection. Let me see if that. Can you see it now?
Yes. Yes.
Okay, perfect. Yeah, so there, I went to campus yesterday and this was not working. So our tech guy did something. So it was working there. And I have been trying since morning to check if at some point, if it does not work, what to do. So last time we were working on 1.3. Anyone has any questions about topic 1.3? So we discuss about the mean, we discuss about the median. Just correct me if I'm not right. We discussed about 5-number summary. Did we?
Yes.
Yes. And we did not talk much about standard deviation, right?
No.
So I am going to go over I'll start from the median. So just a quick recap of what we have done in the last class. And from there, we will start talking about standard deviation. And then our 1.3 will be done. So we talk about how to look at the overall shape of the distribution. So when we are looking at, not the overall, how to look at the overall pattern of a histogram and stem plot. So first thing, we were looking at the shape of the distribution. And the shape is either symmetric or non-symmetric, right? And the second part we did, if shape is symmetric, what is the center? And we say the center is mean, and non-symmetric or skewed, the center is median. Now the third part that we were working on, spread. And when we say that we take center as the median, then our spreads are quartiles, and that's what we did in the last class. And when we take mean, the spread is measured through standard deviation. Standard deviation is denoted by the symbol small s, standard deviation, and we are going to talk about more what is the standard deviation of the population sample in later chapters. Right now we are using a lowercase s symbol to represent our standard deviation, and the fourth was outlier. And when we look at the word outlier, so it has two words, out and liar. So that means that lies something outside the overall pattern. So if our pattern is 2, 3, 7, 10, and the last number is 100, I can see that it is lying outside my overall pattern of 2, 3, 7, and 10, and it's little off. So this is an suspected outlier, and we can find the suspected outlier using our 5-number summary and 1.5 IQR rule. Did we talk about IQR rule last time? Interquartile range rule?
Yes.
And anybody has any questions on that? So let me go back to that part. So 5-number summary, and when you calculate your 5-number summary, you find the range using this 5-number summary. The range is maximum minus minimum. And once you get the range, you can calculate your median, which is the center. And once you know the median, you can calculate your quartile 1 and quartile 3. How we calculate the range using maximum minus minimum, or you can say the difference. Similarly, we can calculate interquartile range, which is Q3 minus Q1. Once you have the interquartile range, we use 1.5 IQR rule to find the suspected outliers in your data set. Once you have this, so you do your upper quartile plus this, and your lower quartile minus this, and then you get the numbers. I'm just writing some random numbers. Let's say it's 120 and this is 20. Then go back to your data set. Now this is your range. Anything outside this range in your data set is an outlier or a suspected outlier. If something is above 120 in your data set or something below 20 in your data set, they are suspected outliers. And here again, I'm taking random numbers. So this is not the case like every time you look for 20 and 120. It depends on when you calculate your quartile and interquartile range and you work on this, the two numbers that you get, anything outside, below, or above is your suspected outlier. Once you know your 5-number summary, you can also make a box plot. And box plot is also one of the graphical representation of your numerical variable. To make a box plot, you need 5-number summary. So 5-number summary, we have minimum, maximum, median, Q1, Q3. So when you make a box plot, that means you're making a plot in which you have a box. So you are going to make a box using this information, Q1 and Q3. You can make your box plot either horizontal or vertical. So let me see if I'm making this. So this is my box starting from Q1, ending at Q3, and wherever I have my median, I will draw the median here. Then since you start from here, so your minimum should be going down, and draw this curve, and same thing, your maximum going this, draw this. And that is your box plot. Box plot help us to see the shape of the distribution. It also help us to see interquartile range, and we can compare side by side box plot also. So if we have 3 or 4 box plot, we can compare What is the shape of the distribution here? Which one has higher median, lower median? What's their interquartile range? So you can compare side by side box plot also. I think I mentioned in the last class, if not, you will not be tested on making a box plot. You will be tested on reading a box plot. What is this value? How much is the distance from here to here? Or what is interquartile range? Looking at the box plot, what do you see? The shape of the distribution. Is it right skewed or left skewed? So you'll be tested only on understanding or reading the box plot. There is no question in any of your assignment or in your test where you have to make a box plot. You just need to know how to read that box plot. Questions? So this is what we have done in the last class. So let me start with the standard deviation. And when do we use standard deviation? When we use mean as the center, right? So standard deviation helps us to find the spread around the mean. So here, measuring variability or spread using standard deviation. Standard deviation summarize how much observations vary from the measure of the central mean. So let's say if I have a density curve, and we will talk more about this in the next topic. And let's say this is my mean. How much is this observation away from the mean? How much is this away from the mean? How much is this? So it tells us the spread around the mean. And when I'm saying mean, I'm looking at the center. And since it's a symmetric distribution, I'm using mean as the center. So for finding the standard deviation, we use the formula for standard deviation as summation of xi minus x bar square n minus 1 divided with the square root sign. And let me tell you, where is this formula coming from? When I look at this is nothing, it's the mean, right? The sample mean that we calculated, x bar. If I have 2, 3, 4, 5, 6, how do I calculate mean? I add everything, divide with the total, I get x bar, which is how much? 20 by 5, 4. So my sample mean is 4, or x bar, or mean of the distribution is 4. So if I take this, then I subtract from each observation. And then I do the square and add everything. It looks like so much when I'll just look at the formula. But we will do an example, and that example will help you understand how to calculate standard deviation using this formula. And again, you can calculate manually if you have a small data set. And if you have a larger data set, let's say you have 2,000 observations, you can still calculate manually, but it will take so much time. So use some kind of software to work on that. And for small data set, you can also use your calculator. So in this class, you can use calculator for any homework, quiz, or exam. So make sure you understand how to calculate standard deviation using calculator as well. Document is uploaded on Canvas, how to use TI 8384 to find 5-number summary and standard deviation. You can find that resource on Launchpad also. So let me go to the slides and then we look at the example on standard deviation here. Questions so far? Excuse me. So the most common measure of spread looks at how far each observation is from the mean. And this measure is called standard deviation. We denote standard deviation with the symbol Sx. And why we are using x here? Because our observation are all in x. You can take y also, z, any x, y, or z, depending upon where you are putting your data. The standard deviation x-axis measures the average distance of the observations from their mean. It is calculating by finding, and read this word that describes the formula. It is calculated by finding an average, which is mean. So first we are finding the mean of the square distance and then subtracting mean from each observation and then doing the square. and I will tell you why. And then taking the square root. And why we are taking the square root? Because variance or variability, we use this formula. Xi minus x bar square over n minus 1. And again, we have n observations, and we are subtracting 1 from it. And we call it as degrees of freedom. And we will talk more about degrees of freedom in later chapters. Right now, you can understand that I'm subtracting 1 observation from my total. So this is your variance or variability around the mean. And standard deviation is the square root of variance, like how we discussed in the last class, I guess. So when we are working on this, standard deviation is the square root of the variance. And when you do the square of that, you get standard deviation, square root. So here is an example. Just let me know quickly that, did we talk about this example in the last class? No, yes?
No.
No. Okay, perfect. So consider the following data on the number of pets owned by a group of 9 children. So you have a data set where you have the data set for 9 children and how many pets they have. You plot that on a number line and calculate the mean. So mean is nothing, it is the average. So look at your data set, which is given here. So this data set is given in here, and we denote it as xi. So my number of observations, or how many observations I have, I took it in variable x. So I wrote xi. So this is my x1, this is my x2, and keep on going. And this is what given to me, 1, 2, 3, 1, 3, 4, 5, 6, 7. So my first step is, when I'm calculating standard deviation, I add everything and divide with the total to get the mean, and which is done here. So once you get that mean, this mean is your 5. So you add everything, divide with the total, you get the mean. So mean is basically, we are saying that it is the balancing point or the center. So here we have 5. Now if I'm going to look how far is 8 from my mean, so I'm talking about how far or how much is the distance from mean until I reach 8. So I can see I have 1, 2, and 3. So I move 3 deviation to the right of the mean to get 8. Similarly, if I'm looking for 3, if I'm looking for how far is 3 from my mean, if I'm looking for 3, so that means I'm going on the left side of that. So if I'm going on the left side of that, 3 is lower than 5. So I know that when I subtract 3, I subtract this, I get negative 2, right? So this negative 2 does not represent that I have negative 2 deviation. This negative sign tells us that I'm going to the left of the mean. Positive sign tells us that I'm going to the right of the mean. So think of standard deviation as a distance. And my distance cannot be negative. Distance is always positive. It's just like if you go in the right direction or the left direction from where you are starting, or where your starting or middle point is. So here you see this negative sign. This negative sign is telling me that I'm going to the left of the mean. And this positive sign or positive deviation telling me that I'm going to the right of the mean. So first thing, you calculate your mean. Once you calculate your mean, then find the deviation for each. And when you find the deviation for each, you will get negative as well as positive. So you get negative for every left side value, and you get positive for the right side. So let's come to this one. So this is exactly what we did, xi minus mean. So you can write it xi minus x bar. That's what we are calculating here. Xi is x1, 1 minus 5, 3 minus 5, everything we can calculate. Questions up till this point? So we are just following the formula, calculating the mean, subtracting mean from each observation. Now quickly, if you can do this quick math and let me know how much is the sum for this particular column. We have negative observations, we have positive observations. Any of you? 0. And do you think that 0 is correct? Anybody else want to double check? and that is 0 actually. And why it is 0? Because we are looking at the distance around the mean in both left and right side. And since mean is the center, it has exact on the left and right. So when we are talking about this should be 0. And why it is 0? We have negative as well as positive. So when we add negative and positive, it comes out to be 0. And if it's 0, we cannot just work with this to calculate anything. So what we do the square of that so that all our negatives comes out to be positive. So it's -4, we do the square, it becomes positive, positive, positive. And now all my observations are positive. And since this is the mean, that's why it's 0 at both. Square of 0 is also 0. And now you add everything, you will not get 0 because we do not have any negative numbers now. So when you add everything, you get 52. So now you are going to use this. And if you remember the formula that we just talked about, it's this. And this is called summation. So sum of all of this. So this sum is denoted as sum of xi minus x bar square. So we calculated xi minus x bar for this, and then we added everything, and that is my sum, which is 52. And then I will go back to my formula, which is this, divided with n minus 1 square root to calculate the standard deviation. So xi minus x bar is 52, we calculated. I have number of observations 9 minus 1, and then you can calculate your standard deviation. Or you can calculate this first and then do the square root. You can use this. This will give you your variance, 52 over 9 minus 1. And once you have the variance, then divide with, and then do the square root, you will get the standard deviation. And if you look at the bottom, it says that average square deviation 52 and minus 1, so that is your variance. And when you do the square root of the variance, you get standard deviation. You do the square of this, you get variance. So any questions how to calculate standard deviation? Again, this is how, or this is the logic behind calculating the standard deviation. Again, you don't have to do it manually. Now you understand how to do it, so you can use your calculator, you plug your numbers, and it will provide you the answer. So please check that document and solve the same example using your calculator and see if you get the same result. Properties of the standard deviation. So when we say standard deviation measures the spread around the mean. And when we are saying spread around the mean, so that means the shape of our distribution is symmetric, because we use mean as the center when we are talking about symmetric distribution, right? We don't use mean as the center for skewed distribution because mean is not resistant to outliers. Mean will change if there are outliers in your data set. Median is resistant to outliers, so we use median for skewed distribution. So we use mean as the center. We are using spread as standard deviation. When we are seeing spread as standard deviation, so we say that spread is like the distance around the mean or the deviation around the mean. Can the deviation or can the distance be negative? We just talked about this. The distance can not be negative. So your standard deviation can never be negative. So your standard deviation cannot be negative. If it's not negative, that means it is positive. It is always positive. So standard deviation is always greater than 0. So when I say always greater than 0, can I also say that standard deviation is greater than or equal to 0? Can we say that standard deviation can also be equal to 0?
Yes.
Yes. So we can also say that standard deviation be equal to 0. And how or why? Why it's not negative, it's always positive, but how can it be 0? Standard deviation is spread around the mean, and how that spread or the distance be 0? Think that I took test 1 and all of you scored 95. I'm very optimistic, by the way. So everybody scored 95. If I'm looking at the mean, what will be my mean? 95. And if I subtract that from each of this, what will I get? 0. So your standard deviation can also be 0 if you have the same observation in your data set. If all your observations are same in your data set, let's say 333, 555. So that means when you calculate everything, find the mean is the same number. And when you subtract the mean from each, it is 0. So there is no spread. So there is no spread because, and then we can say that standard deviation is 0. But we can never say that it's negative. It will not be less than 0. So these are the properties of standard deviation. Standard deviation is 0 only when all observation has the same value and there is no spread. Otherwise, it's always positive or greater than 0. We discussed it is not resistant to outliers. Why? Because it works with mean. We subtract mean from each observation, and mean is not resistant. So does standard deviation. It has the same unit of measurement as the original observations. All right. Choosing measure of center and spread questions? Anyone has any questions for me? All right. If not, let me move on. Choosing measure of center and spread. Again, we just discussed when you know the shape of the distribution. If it's symmetric, choose mean and standard deviation as the center and spread. And if it's skewed, choose this. The median and interquartile range are usually better than mean and standard deviation, describing a skewed distribution or a distribution with outlier. And use mean and standard deviation only for symmetric distribution. And the last part, very important, numerical summaries do not fully describe the shape of the distribution. You need to always plot your data. Let's say you have 5-number summary. That summary is not enough to describe the shape of the distribution. If you have the data set, make sure you plot your data and look at the answer or look at the shape of the distribution. Changing the unit of measurement. Variables can be recorded in different unit of measurement. Most often, one measurement is called your linear transformation of other measurement. And linear transformation do not change the basic shape of the distribution, but they do change the measure of center and spread. Sometimes the distribution is not given to us in a clear form, so we do transformation. And linear transformation or log transformation are the important ones that we do. But again, when we do the transformation, we work on that. And once we get the result, we will bring our observations, or we can bring the unit of measurement again back to the original one. And this part, again, this is just to make you understand that there are transformations and we do not get the data that sometimes we do not get the data very clear form. So we do some transformation, we work on that. But again, you will not be tested on this topic because we are not doing that in detail. 1.4, density curve and normal distribution. This topic is very important, and I mentioned in my email that we are going to use this topic in later chapters also. So please, at any point, if you do not understand, stop and ask. Or if you don't feel comfortable during the class, stop at my office hours, and office hour does not work, send me an email and we will definitely set up some time. So we are going to talk about density curves and normal distribution. What is a density curve? What do we mean by normal distribution? If we have normal distribution, how do we represent normal distribution? And how do we find area under the curve? Can we standardize the observations? How do we do? And we are going to talk about all this in 1.4. So it is quite big topic, but again, very important and useful topic. So let's quickly talk about density curves and measuring center and spread of the density curve in normal distribution. So I will not start this topic today because again, it's very important. So hopefully I will be able to cover this. If time permit, I'll just introduce this one. So when we are talking about density curves, so let's start here. We now have a kit of graphical and numerical tools for describing distribution. We also have strategy for exploring data on a single quantitative variable. Now our fourth step is draw a density curve. So we did first one, always plot your data, make a graph. Look at the overall pattern, shape, center, spread, and outliers. So this is what we just did. Calculate the numerical summary. We did that. So we did first three parts. We'll plot our data. First, we look at what kind of variables we are working. And then when we are working with numerical variables, we look at the shape, center, spread, and outlier. And then according to that, we use mean, median, standard deviation, or quartiles. We make 5-number summary. Once we are done with this is our fourth step. Sometimes the overall pattern of a large number of observations is so regular that we can describe it as a smooth curve. And that smooth curve is called your density curve. And when we say density curve has two properties, and all density curves should have those two properties. So if you're saying this is a density curve, you need to satisfy those two properties first. So here, let's say you have a histogram and then you draw a smooth curve on top of a histogram, and that is your density curve. So a density curve is a curve that is always on or above the horizontal axis, and it has an area of exactly 1 underneath. So if I'm making a density curve on top of a histogram, so this has area 1 whole, or you can say 100%. So it has an area 1 whole or 100% inside this density curve, and it is on and above the horizontal axis. Let's say if I draw it here. So it is on and above horizontal axis, and it has an area exactly 1 underneath it. So if you are looking for a density curve and you need to satisfy, if the question is asking, is this a density curve? Then you need to satisfy these two properties. And if those two properties satisfy, yes, this is a density curve and you are working with it. And what does density curve do? It describes the overall pattern of a distribution. The area under the curve and above any range of values on the horizontal axis is the proportion of all the observations that fall in that range. So this is the definition of a density curve. And these are the two properties that we need to satisfy if we talk about a density curve. And this is what we talked about earlier, but let me quickly go over that. Our measures of center and spread apply to density curve as well as to actual set of observations. The median of a density curve is the equal area points, the points that divide the area under the curve in half. And when we talk about mean is the balance point. That is the point which the curve would balance if it will made of solid material. So when we say median, we say that the density curve, the median of the density curve is equal areas divided into 2 equal halves. And when we are talking about mean is the balancing point. So that's why mean goes in the direction of the tail when we talk about the right skewed or left skewed distribution. The median and mean are same for symmetric distribution. So if this is symmetric distribution, both mean and median, they are same. Mean equals median. But when we talk about skewed distribution, mean is sometimes higher than the median and sometimes it's lower than the median. So here we are looking at the right skewed distribution. The long tail put the median to the right. The tail of the distribution is on the right side. Excuse me. So the mean is on the right side. So mean is greater than the median. Because if I start from 0 here, this median is before and then mean is after. So mean is bigger than the median. And same thing if I'm working with left skewed distribution. My median is here and my mean is here. So mean is smaller. So mean is smaller than the median for left skewed distribution. Again, if we know just the mean and the median, we can find out the shape of the distribution. If I know my mean is 5 and my median is 7.5, and I have no other information, and on the basis of that, I need to tell if it's a symmetric distribution or a skewed distribution. Can I do that? Yes, we can. So we can compare these two, mean and median. Are they equal? No, they are not equal. So that means it's not symmetric distribution. Is mean greater than median? No. Mean is not greater than median, so it's not right skew. Mean is less than the median? Yes, so it is less skewed distribution. If we have to take the decision on the basis of just this information, then we can also take that. Density curve. The mean and standard deviation computed from actual observations are denoted by X bar and S. So in our previous 1.2, 1.3, we are denoting mean with this and standard deviation with this, right? When we talk about standard density curve, we change these notations. So these are the notations that we use for actual observations for the data that we are using. But when we plot that on the data set using a histogram and draw a smooth curve on that, now if we are denoting mean, we use a Greek letter mu to denote mean and another Greek letter sigma to denote your standard deviation. So this is for your actual observation from the data, and these are the symbols that we use for our density curve. So mu and sigma, and get used to of this because we are going to use that throughout the course. Then we are using density curve and we are using mean and standard deviation as mu and sigma. Normal distribution. Now we are talking about normal distribution. What is normal distribution and how do we denote normal distribution? Again, when we are talking about normal distribution, it is a density curve, but it has some properties that need to be satisfied to say it is a normal density curve. One particular important class of the density curve is the class of normal curves, which describes normal distribution. When we talk about normal distribution, all normal curves are symmetric, single-peaked, and bell-shaped. And what do we mean by single-peak? So that means there is only one peak. There can be two, there can be three, there can be more than. So we call this as, if there is one peak, we also call it as unimodal, one mode. When we have two, we call it bimodal. And when we have so many, we call it multimodal. And there is a question in your homework assignment to look at if they are single peak, unimodal, bimodal, multimodal. So when we talk about normal distribution, they are symmetric. Again, symmetric, that means they have the middle in the center and dividing into two equal halves, roughly the mirror image of each other. Single peak, that means they have only one mode or one peak or one top. And bell-shaped. So if you look at the shape of this distribution, it is like a bell, right? If you have, or this. So this is also bell-shaped. But again, you see one is spread out more than the other. This one is spread out more. This one is spread out less. So one is like this and one is like this. And why these shapes are different? The shapes are same, but one is narrower, one is not. And why? Because this one has more or higher standard deviation and this one has lower standard deviation. So it depends upon what your standard deviation is, and then you can see the shape of that density curve. The shape is bell shaped, but is it spread out or is it more narrower, wider? Depends upon what is your standard deviation. So again, normal density curve, always symmetric, single peaked, and bell-shaped distributions. And we denote normal density curve. Since it's normal, we use uppercase M. And when we are using density curve, we use mean as mu and standard deviation as sigma. So we use this notation for normal density curve. So this is your mean, and this is your standard deviation. And you can also write as mu and sigma squared, and sigma squared is your variance. We know that standard deviation squared is your variance. So if you know your variance, you can calculate your standard deviation. If you know your standard deviation, you can calculate your variance. So this is standard deviation and this is your variance. A specific normal curve is described by giving its mean mu and standard deviation sigma. So here is your actual definition of a normal distribution with everything in it. A normal distribution is described by a normal density curve. Any particular normal distribution is completely specified by two numbers. One is your mean and another is your standard deviation. The mean of the normal distribution describes the center of that normal curve, and standard deviation tells us how far each observation away from the center or the distance from the center to the change of curvature points on either side of the center, either the left side or the right side of the center, if this is my center. So if I'm describing a normal density curve, single bell-peaked and single peaked, bell-shaped, and symmetric distribution, then I can describe that as mu, my mean. And let's say if this is the spread I'm looking, this is my standard deviation. Same thing I can do it here, or here, or here, and keep on going, depending upon if I know how much is my standard deviation. And we denote normal distribution with mu, n, mu, and sigma. Questions? Everybody good, I guess? So let me just talk about 689599.7 rule since we have 10 minutes. But again, I will start from this topic in the next class also. So when we are talking about 689599.7 rule, this rule is also called as empirical rule. And again, this rule is a first-hand rule that we use to look at how much is the 95% area, or how much is the, how many, how much observations, or if I look at a density curve, 95% of the area is contained, how many observations in that, or how much is that, what are the values for this, what is the limit. So I can look at that 68, 95, or 99% of the observations within 1, 2, or 3 standard deviation around the mean. So let's use this. So if we have a density curve, so let me use this one. So if we have a density curve, and let's say this is my density curve and this is my mean mu. If this is my mean mu, so that means this is the center. And if I'm using mean as the center in the density curve, my condition is that it is symmetric, right? It is a symmetric distribution. It's dividing into 2 equal halves. So my left hand side and my right hand side and my left hand side, it's dividing into 2 equal halves. Now I'm talking about 689599.7 rule. This rule is applicable only when my distribution is normal. So you can use this rule when you are working with normal distribution, and we will talk about sometime you don't get normal distribution. So you are going to use this rule when we are talking about normal distribution. In that, we can calculate 68, 95, and 99% observation, or we call it 99% rule, and we call it as empirical rule also. So this rule tells us that if I'm moving 1 standard deviation to the right, or I'm moving 1 standard deviation to the left. So if I move 1 standard deviation to the left and right of the mean, it will give me 68% of the area under this density curve. So when I move 1 standard deviation to the left and right of the mean, it covers 68% of the area. And if it says 68% of the area, so I can say that 68% of the area is within 1 standard deviation to the left and right of the mean. And within 1 standard deviation, I'm saying when I go here, I will add. But I go here, I will subtract. So you can write it this if that makes more sense. So I will subtract, and let me just take some numbers. So let's say my mean is, I'm talking about a normal distribution, and I say this. If this is given to us, how will I read this? I'm talking about the normal distribution with mean 10 and standard deviation 2. So let's say my mean is 10 and standard deviation is 2. So I'm moving 2 and 2. So if I move from here to here, what will be this number? I'm adding 2 observations, right? So it will be 10 plus 2, which is 12. So mean plus my standard deviation. And if I'm moving back, so I'm moving 2 units back. So that will be 10 minus 2, which is 8. So this is 8, this is 12. So when I'm talking about 68% of the observations or 68% area under this density curve, it is in the range of 8 to 12. So if I'm looking between 8 to 12, I have 68% of the observation or 68% area. And since I'm talking about symmetric distribution, so that means this will divide into half. If this is 68%, that means this is 34 and this is 34, right? It's dividing into 2 equal halves. So this is also 34 and this is 34. When I combine it, it was 68%. Questions? So if I'm looking for the 68 using this information, I can say that 68% is in the range of 8 to 12, right? Where my mean is 10 and I'm talking about 8 to 12. Similarly, since this rule talks about 68, 95, and 99.7%, so I talk about 68. When I talk about 95, 95% says that the area is between 2 standard deviation. So that means I'm moving 1 more. And this is my mu plus sigma plus sigma. So this will be mu plus 2 sigma. And same thing, I'm moving here also. So this will be another sigma, sigma. So mu plus sigma plus sigma. So 12 plus 2, this will be 14. And this will be 6. Now what can I say? So now I say that this thing is 95%. Because I'm talking about 2 standard deviation, I'm moving 2 standard deviation to the left and right of the mean. And if I'm saying this is 95%, this should be the half of 95%, right? And this should be the half of 95%. I know this is 34. If I can find the half of this, I can also find this part, right? So this will be 95. Half of 95 is 47.5%, right? And this is also 47.5%. So since I know this is 34% and this whole thing is 47.5%, can I calculate this particular part? So if I subtract 34 from 47.5, I will get this part, which is 13.5%. And if this is 13.5%, my right side is also 13.5%. Why? Because they are symmetric distribution. This is also 47.5 and this whole thing is 34 and I subtract, I get the remaining. So this is when we talk about 2 standard deviation, 95%. So we know 68, 1 standard deviation to the right and left of the mean. 95, 2 standard deviation. Again, we are talking about normal distribution. And when we, let me use this. So when we are talking about 3 standard deviation, when we are moving this is my 99.7%. And when we are talking about 99.7%, half of this and half of this is, you divide this with 2 and then you get the half of 99.7, and which is 49.85. So calculate this one. 99 is 49.85, I guess. Let me. So check this part. When half of 99.7 is there, we know that this whole thing is 47.5. And when we subtract this 47.5 from this, we get this part, which is 2.35%. And same thing you get here. And when we add everything, it adds up to be 99.7. When it adds up to be 99.7%, that means we are still missing 0.3% from the whole. So when we are saying we're still missing 0.3%, and we know that this is a normal density curve, the area under the curve should be 1 whole or 100%. So that means we need to include this. So the tails that are left, that is the remaining 0.3%. And when we are saying 0.3%, that means we are dividing this 0.3% into 2 equal halves. And when we divide this, this will be 0.15 and 0.15. And when you add everything, it adds up to be 1 whole. This looks a little messy here, but if you go to your Stat 108 notes and you look at 1C, and these notes are uploaded for you on the Canvas. So you look at this part, and this is the cleaner version of what we just did. So if you go to 1 standard deviation, take that as mu, and sigma, sigma, sigma. And then you can say that 34%, 34, 13.5, 13. So this is your 68%, this is your 95%, and this is 99.7. And the remaining, after doing 99.7, we still have 0.3 left to make it 100. So we divide this into 2 equal half to get this 0.15 and 0.15. And there are some examples solved in these Stat 108 chapter notes. So make sure you go over that. This is uniform distribution. We didn't talk about it yet, so don't worry about this part yet. Just look at the 68, 95, 99.7. We can use that only for the normal distribution. And then I will come back. And on Friday, we will do the remaining of this chapter. And it's already 11:51, so over 1 minute. Sorry, guys. Thank you, everyone. Have a wonderful day, and I'll see you guys on Friday.
Bye.
Thank you.
You're welcome.